Hello, dear friends. We are starting the solution of Physics 105, Spring 2018-19 Midterm 1. In the graphs 1, 2, 3 in the figure below show how the velocities of different objects moving along the x-axis vary with the time t. The possible acceleration ax of the object as a function of t are shown in the graphs 4, 5 and 6. Match the vt with the at that best describes the motion. Let's start with the first graph that describes the motion of our object. What is the relation of the velocity with the time in this graph? As you can see, the relation is linear. The possible equation for the v is, we can see as at plus v0. That is the relation between v and t. And as we know, ax is equal to derivative of velocity over time, with respect to time. Let's take the derivative of first order. So, ax should be equal to constant. Which graph shows constant? Fifth graph. Our fifth graph shows the constant relation between acceleration and time. Let's come to the second one. Second graph, as you can see, shows the relation between velocity and time as exponential. So, if v is related with t as the second order, so dv over dt should be related with first order, which shows that our relation should be like line. Which graph shows this? Fourth graph. So, our next page is 2 and 4. Let's come to the last one, which describes the motion as linear and constant. So, derivative of the velocity at the first part should be one constant line. At the second part should be 0, because dv over dt is equal to 0 if v is equal to constant. So, our answer is B.
Now we are doing question number 2. And the question number 2 is, the figure below shows the graph of position x versus time t for a train moving slowly along a straight track. Which of the following statements is true for the motion of the train? So in this question we are given a position time graph, and as you can see, this is the position time graph, and from time t is equals to 0 to time t is equals to 2, position, just writing x, is increasing linearly. And as you know, the velocity is equals to derivative of dx over dt or the slope of the position time graph. So as it's increasing linearly, the velocity will be a constant number. So as you can see here on this graph, velocity time graph, from t0 to t2, it's a constant number. So from t2 to t8, velocity position is increasing exponentially, and here it's increasing like there's an increase in the gradient. So here we will have a straight line from t2 to t is equals to 8 seconds. From t8 till t12, x is decreasing linearly. So here we have a negative gradient as it's decreasing, and since gradient is constant, so our velocity will be a constant number here. And at t is equals to 12, the position is 0, so our velocity will also get to 0 because the point it started, it came back on the same point, so our velocity will be 0. Okay, now in the question we have 5 choices. First one is the train always moves in the positive x direction. Now it moves in the negative x direction as well. From this graph you can easily do. The average speed of the train for the entire trip from 0 to C is 0. See, it's saying about speed. Speed cannot be 0 because its position is increasing. Position or distance is increasing. And choice number C is the train moves with a constant velocity over the interval from time is equals to t is equals to 6 to t is equals to 10 seconds. From t is equals to 6 till t is equals to 10 seconds. Now the velocity from t is equals to t equals to 6 so t is equals to 10. Now from t is equals to 6 till t is equals to 10, the position is increasing exponentially. So it's what can you say? Its velocity is not constant; it's also increasing linearly. And in choice D, it says the average velocity of the train for the entire trip from 0 to C is 0. Yeah, in this case, we started from this point and we ended at the same point. So our position will be 0. That's why our velocity will be 0. So D is the right choice. I'm going to write it here.
So guys, we are solving question 3 now. So the question 3 reads as this: a car moving with an initial speed of 50 kilometers an hour can uniformly come to a stop in a distance of 24 meters after the brakes are applied. What will be the stopping distance of the car if its initial speed is 100 kilometers per hour? So it's basically asking, like, it's given you a sample equation. It has given you the initial speed. Whenever you see the word uniformly, just understand that we need the acceleration. Like, just find out the acceleration is constant. You can use one of the 4 accelerations question, constant acceleration equations we have. We'll put a link down below. So we will solve it like this. We have the initial velocity 50 kilometers an hour. Our final velocity is 0 as it's a stopping distance, so it will be 0. We have to find out the acceleration. We have the stopping distance, this is 24 meters. So we'll use one of the most common equations here. So this is v final squared minus v initial squared is equal to 2 times acceleration times stopping distance. Just plug in the numbers and you're going to find out the acceleration to be minus 52 meters per second squared. So we now have the acceleration. Let's find out the stopping distance when we have velocity, initial velocity as 100 kilometers an hour. Use the same equation. It's very easy. Use the same equation, plug in the numbers. I won't do the maths here, like it's a very basic math. So our stopping distance will be around 96 meters. You can get 100 or 90, but it's the most nearest to the C part, which is 96 meters. So This is the answer, because C is the answer for question 3. Okay, now guys, we are going to solve question number 4. So the question 4 reads as an object thrown vertically upward from the ground level at time t is equal to 0 reaches its maximum height at t is equal to 2 seconds. How high above the ground is the object at t is equal to 3 seconds? So it's a very classic case of projectile motion. We are giving the time, we know the acceleration is equal to the gravitational constant, and it goes like that. The game plan for this question is to first find the height. Basically we need to find the velocity at this point, the velocity at the highest point, what it is. To find that, first we have to find the how high it is from the ground. To solve that, we will use this equation. Change in displacement is equal to initial velocity times t plus 1 upon 2 at square. We have the its initial velocity is thrown from ground level, it's 0, and we can plug in the numbers. We get 20 meters at its height. This is written down here. Now use this equation. Now we need to find the velocity at the topmost point. So final velocity squared minus initial velocity squared is equal to 2 times acceleration times displacement. We have the acceleration, we don't know the final velocity, we know the distance covered 20 meters. Plug in the numbers, we have the final velocity as 20 meters per second. Tamam. Now we will use one last final equation to find the displacement at t is equal to 3 seconds from the ground. Change in displacement, we will use the same equation as the previous in the first one. Change in displacement is equal to initial velocity times t plus 1 upon 2 at squared. Plug in the numbers, you're going to find out 15 meters. That's, I think, option C. So this is our solution.
So in the fifth question, it says that an object is thrown vertically downward from a height of 15 meters above the ground level with given initial speed. So we can draw it firstly. So you can draw like that. The v initial equals the minus v because you thrown the downward, and we don't know the v final. We hit the object ground, and we know the how many meters above the ground. It's 15 meters. So after that, at exactly the same time, a second object is thrown vertically upward from the same height with the same initial speed. So you can choose like that because at the same time it means the t equals each other. So when thrown upward, it goes the maximum height will final initial velocity final equals to 0. So second object it's reached the maximum height. Find the initial speed of the object. So firstly, he wanted from us the velocity. So we can, it's the projectile motion. So we can use the Vy equals V initial minus GT. So doing that for first object. So V final equals, for here it's minus V minus G is equals 10 times T. And here, for second object, we know that the maximum height is equals to V final equals 0. So we write that V final 0 equals V minus 10 times T. So we can equals like that, V equals 10 T. So we write in the first equation here 10 T. So V final equals minus V equals V final, we found that minus 2V. So we write that here to minus V. So we can use the other projectile motion equation. It's the V final square equals V initial square minus 2G delta Y. So we find the delta Y first. Delta Y equals U final minus U initial. So the V final here, it will be 0 and minus the first Y initial equals 15 meter. So it means your displacement is minus 15 meter. So you can write here now. So we found that the 2 minus V square equals minus V squared. V initial is here, and 2 times g is equal to 10, 2 times 10 minus 15. So we take the square, t v square equals v square plus 200. So you can do the equation. So it means 3v square equals 200. So v square is 100. So it means v equals plus minus 10 meter per second. So it wants the magnitude of this. So you can do the absolute value. So the v equals 10 meter per second.
Okay, so we're going to solve now question 6. So question 6 and 7 are interrelated. As shown in the figure below, a ball is thrown from the ground level with an initial velocity of vector 6i plus 8j meters per second towards a high wall. The ball hits the wall 3 meters above the ground. So the question 6 is find the initial speed and the projection angle of the ball. So basically it's asking us to find the just take the, the method of hypotenuse, right? We have this velocity, we derive it from the hypotenuse. We know the y, we know the x. Our y is 8j, our x is 6i. So the famous equation of the hypotenuse. Plug in the numbers, you're going to get the whole velocity, initial velocity as 10 meters per second. So now for the angle, you can just refer to the triangle below. Use this formula. This is tan theta is equal to y divided by x. Use the arctan, find the angle 53 degrees. It matches with answer A. So now we are going to shift to question 7. So question 7 is, if the velocity of the ball as it hits the wall is given by vector f 6i minus 2j meters per second, find the horizontal distance d traveled by the ball. So it's just basically asking us, they have given us the height of it, that's 3 meters. We're going to find now the distance covered by the ball. This is a very easy question. So first we have to find this, put it on this equation of the constant acceleration. V final is equal to V initial plus AT. We have the V final minus 2J. Initial VI as 8J meters per second, and we have the acceleration which is minus 10 meters per second. Plug it in, you're going to find out time is going to be 1 second. So the time is the factor that is going to remain constant if we are going vertical or horizontal. Now we have this other equation with us. Change in displacement is equal to initial velocity times t plus 1 upon 2 at squared. As we know, if we have a horizontal velocity, so our horizontal acceleration will remain 0. So cancel this out. We have change in displacement is equal to 6 times s is our velocity, initial velocity. We got it from here. This is already given to us. We have the initial velocity times 1, that's going to be 6 meters. This is answer B.
Okay, let's continue with 8th question, which tells us that a particle in the xy plane moves with a constant acceleration, and this particle at time 0 are in r initial, which is equal to 4 over r initial, as given in question, is equal to 4i plus 3j over v initial is question and over r final at t equal to 2 is equal to 10i minus 3j, and over final velocity is equal to 5i minus 6j meter per second. Okay, let's find the V initial. In order to find the question that asks us about the acceleration of particle here. Okay, let's resolve R as X and Y. Let's say that X final is equal to 1 over 2 a t square plus V initial for X again T plus X initial. So over delta X should be equal to X initial and X final should be equal to 6, which is equal to 1 over 2 AX times 4 plus 2 VIX. We here subtract 10 from 4, as you can see. Okay, from this part we have the equation that tells us 6 is equal to 2AX plus 2 V initial X. And also here don't forget that V is equal to V initial X I hat plus V initial Y J hat. Okay, let's write here the equation which tells us about relation between V final and acceleration in this part. Again, don't forget that V final is equal to V final Y I hat plus V final by J hat. So from here we can say this, that phi is equal to 2 AX plus VIX. Okay, we have these two equations for now. Let's multiply by -1. Now we can take from here 1 is equal to, if we multiply the both part, if we multiple the both part by minus sign, we should have V initial X is equal to 1. From here, if we put this V initial on the upper relation, we will take AX equal to 3. That was the thing for the X component. Let's do the same for Y component. From here we can tell that Y final is equal to 1 over 2 A Y T square plus V initial Y T plus Y initial. So from these relations we can tell that over delta Y, which is equal to Y final minus Y initial, and in this situation -3 minus again 3, it should be equal to -6, which is equal to 2AY plus 2VI. Okay, now let's write the same equation that we have written for the X component. Here, the initial I. So, V final I is equal to, V final Y is equal to -6 again, which is equal to over AY, that is unknown, 2 plus V initial I again, which is unknown. From these two equations we can tell that again multiple by minus sign, and let's sum up over V final is -6. If we sum up here, we will take V initial Y equal to 0. In this situation, if we put here 0 over AY will be minus 3. So we got AX as a 2. Sorry, by the way, it was 2 in this part. We got AX as a 2 and AY is minus 3. So our answer A is equal to 2I minus 3J meter per second square, which is C.
Now we are doing question number 9. The question is the position of a particle moving in the xy plane is given by r is equals to 5 plus 4t square I minus t cube j, where r is in meter and time t is in seconds. In question number 9, we have to find the average velocity of the particle between t is equals to 1 second and t is equals to 3 seconds. So we have the position vector and velocity is equal to derivative of the position vector. So its derivative will be 5 is a constant, so its derivative is 0, and 4t square will be 8t minus t cube will be 3t square j. At t is equals to 1 second, velocity will be equals to 8, and we plug 1 in instead of t, so 8i minus 3j. At t is equals to 3 seconds, velocity will be equals to 8 multiplied by 324i minus 3 multiplied by 3 squared, so it will be 27j. To find the v average, we are going to add both the velocities and divide it by 2. So 8i minus 3j plus 24i minus 27j. So add I component to I component and j components to j component. So 8 plus 24 is 32 and minus 3 minus 27 is minus 30 divided by 2. So your average velocity will be 16i minus 15j. So, and question number 9 and 10 are connected. So in question number 10, it's asking us the magnitude of the acceleration at time t is equals to 1. First we will calculate acceleration by taking the derivative of velocity function, and as you know, velocity is equals to 8ti minus 3t square j. Its acceleration will be 8i minus it is also 6tj. At t is equals to 1, acceleration will be equals to 8i minus 6j. And now we are going to find its magnitude. Its magnitude is square root of the components. So it's 8 square plus 6 square is equals to 64 plus 36, and which is 100, and then we take its square root and it will be 10 meters per second square.
Okay, let's continue with question 11. That says us which of the following statements is true for an object in uniform circular motion. Yes. Our first choice tells us that its velocity and acceleration vectors are perpendicular. However, in the circular motion, our acceleration and not parallel to the velocity, because as you can see in these two graphs, every time acceleration is toward center, and because of this. Because that acceleration is toward center and perpendicular to the velocity, our choice cannot be A. So A is eliminated. Let's come to B. Its average velocity is always 0. No. Why? It's wrong choice. Because our average velocity is equal to distance over time. and we can find some distance that over object passed and the time is not zero. None of them is zero. Distance is non-zero because distance is not zero and also time is not zero. So B is eliminated. And also you can see from here that we have V1, V2, and again V average cannot be zero. Let's come to choice C. Its acceleration vector is constant. As you can see from this graph, acceleration constant change, acceleration vector change. But what is important here, and please notice, acceleration is not equal to magnitude. Acceleration vector is not equal to magnitude because acceleration changes by time. For example, you can see here acceleration can be equal to I, here can be equal to minus j, here it can be equal to minus I plus j, and it's so vector is so important, and you will see in next courses vector is not equal to magnitude and scalar. Let's come to choice D, which says that velocity is always perpendicular to acceleration, and that is correct. Let's come to choice D for next one, for choice E as a last one. In here say its velocity and, let's come to the choice E, the last choice. Its velocity vector is constant. No, because velocity vector at first position is, as you can see from here, is much more different than velocity vector at second position and third position. So this choice is eliminated. Okay, let's continue by question 12, which tells us that a river is flowing from west to east, as we show here by the vector from west to east. At a speed of 1 meter per second, a swimmer on south bank of the river is capable of swimming at 2 meters per second in still water and wants to cross a river along the shortest path. He should swim in the direction. Okay, let's come here. Velocity of the river is equal to 1 meter per second and maximum velocity of the swimmer is equal to 2 meters per second. How we can reach the shortest path? We should know that there must be no x component in order to reach shortest path, because if we have x component in the resultant vector, in the resultant velocity, we can't reach shortest path. So let's find the resultant vector, which is equal to v, velocity of swimmer minus velocity of river. Okay, let's find the theta, which is between velocity of the river in y direction and velocity of the swimmer. In this triangle, theta is equal to arc sine of the 1 over 2, and it's equal to 30 degrees. So our swimmer should swim like as 30 from 30.
Ha, devam et.
Son keseriz.
Şey yapacağım, keseceğim.
Güneydoğu demek istiyorum.
Babek. Telefona ihtiyacım var. 2 dakikada şunu bir şey yapsam olur mu?
Bir dakika bunu bitireyim sonra.
Hayır, şeyini açacağım mesela. Şunu. Şunu yerde istiyorum.
So our answer, bro, you will cover this.
Yok canım.
Emre.
So our answer is 30
Bir
degrees.
dakika bekle. Dur. Okay, go on.
30 degree west of north, which is E. So our answer shows E is correct. Okay, let's continue with question 13. An athlete starts at a point A and run at a constant speed of 6 meters per second clockwise around the circular track shown in the figure below. If the diameter of track is 116 meters, find the average acceleration of athlete for the quarter of the track between points A and B. Okay, let's remark some important points. Quarter of the track and constant speed here and diameter. Okay, let's write here the velocity, but be careful please that this is magnitude of velocity, that 6 meters per second. For example, here VA is equal to 6 meters per second J hat, and here J, and here velocity B is equal to 6 meters per second I. So our delta V is equal to VB minus VA, which is equal to 6I minus 6J. Here circumference is equal to 2 pi r, which is equal to 2 times 3 times AT, and in the question given pi given as 3. From A to B is equal to RBA. So the which RBA, as you can see, is equal to, and I mentioned that please be careful about this point, quarter of the track, which is equal to 120. Okay, let's calculate delta t, which we need for average acceleration, which is equal to delta v over delta t. Delta t is equal to distance over velocity. You should know the famous relation that is equal to v is equal to d delta r over delta t. So distance over velocity is equal to 20 seconds. The average in this situation should be equal to delta v over delta t, which is equal to 6 over 20. We find delta v at upside, 6 over 20 I minus 6 over 20 j. So our answer is equal to 0.3 I minus 0.3 j. The choice is E for this question. Okay, let's continue with question 14, which tells us which of the following statement is true for a pair of forces obeying for Newton's third law. Okay, let's come and talk about action and reaction in the Newton's third law. That say if there is a mass with m which acts on the other mass, that it's also small m, let's take it. What's the relation between the forces that they are acting for each of the masses? Okay, let's take this as a first and this as a second. Force 1, 2 is a force that acted from first mass to second, and force 2, 1 is a force that acted from second mass to first mass. Okay, over choice A, say they are equal vectors. Magnitude of them are equal, but F21 is not equal to F12, so they are not equal vectors. They are parallel to each other. As you can see, they are not parallel to each other, and that is other fault. They are perpendicular to each other. As you can see from here, they can't be perpendicular to each other in this situation. They act on different objects. As you can see here, they are acting on different objects. They are acting on different objects. As you can see here, F12 is a force that comes from first mass to second, and F21 is a force that comes from second mass to first one. So they are acting on different objects. Our last choice is telling us that they are acting on same object, which is correctly wrong. So the answer is D.
Okay, so now we are doing question number 15. And question number 15 is, a table is in an elevator that is accelerating upward. A TV is placed on the table and a book is placed on top of the table, on top of the TV. When you draw a free body diagram for the TV, the number of forces you should include in this diagram is. So here you see this is an elevator. We have a table in it and a TV on top of that and a book on top of this, and it's accelerating upward. So now we're going to only consider TV. On TV we have a normal force because of the table, and then we have its own weight of TV and weight of the book which is on top of it. So in total we are going to consider 3 forces, and so our answer will be C, which is 3.
Let's continue with the question 16, which shows us 2 masses that they are connected to each other by on a frictionless horizontal surface, and they connected to each other by a string, horizontal string. Okay, first let's draw a physical model, and after this let's draw a free body diagram, which tells us about the sum of the forces is equal to sum of the masses time acceleration. In this time, we should notice that both our system is going by same acceleration. Acceleration of our system is equal, and there are no difference. Otherwise, in our system there will be collision. In order to this, our acceleration on each of the masses should be equal. Okay, let's draw a free body diagram. Let's find the equation for M2. T2 minus T1, because in negative direction, which is equal to M2 times A. A here is in this direction. Okay, let's find the A for first mass, which is equal to, if we multiply A with mass, should be equal to T1. So in this situation, if we sum up the equations, we will get T2, which is equal to M1 plus M2 times A. So we have T2, we have T1, let's divide them. What question asks about us? T1 over T2 is equal to M1A over M1 plus M2 times A. A's cancel each other, and our answer for T1 over T2 is M1 over M1 plus M2, which is choice B.
Now we are doing question number 18, and question number 18 is, consider a box resting on a frictionless horizontal surface. A constant horizontal force acts on the box for a given amount of time, accelerating it to some final speed. If the same process is repeated with another box which has twice the mass of the first one, the final speed of this heavier box will be. So in this question we have 2 scenarios. In the first case we have a box and we say its mass is m, and we are applying a constant horizontal force. So F is equals to ma, and acceleration will be F over m. You know, V final is equals to V initial plus acceleration times the time. So in this case the box was resting, so its initial velocity is 0 and its final velocity will be Ft over m. So in the second scenario, now the mass of the box is twice that of the first one. So its mass will be 2m and the same horizontal force is acting on it. So this will be F is equals to 2ma, and then A will be equals to F over 2m. And the same formula we are going to use here, Vf is equals to V initial plus At, as it was also at rest, so its initial velocity will be 0, and then the final velocity will be Ft over 2m. So it's the half of the original one. So our answer will be E.
So now we are going to solve question 19. As shown in the figure below, a child holds a sled at rest on a frictionless snow-covered hill inclined at 30 degrees to the horizontal. If the slide weighs 100 newtons, find the magnitude T of the force exerted by the rope on the slide and the magnitude N of the force exerted by the hill on the slide. So basically we will start by first making a free body diagram. I know I'm bad at drawing. This doesn't look like a child, but we'll work with it. We have a rectangular box here. We have an angle of 30 degrees, which is already given to us. Now everyone, you should know that you have to divide it into components. So our component in this direction is mg sine theta. And our component in this direction is mg cosine theta. And we derived it from mg, and we had an angle over here. We derived it into its component. And n, this is our normal force, Fn. Tamam. Now, as you know, the object, like the whole system is at rest. So we are going to now we are going to calculate the sum of the forces. The sum of the forces in the x direction is equal to 0. So we have one component going this way, which is mg sine theta, and the other, which is the child is pulling, that is the tension T, which is we have to find. They both are equal as the sum of them, as the difference of them is 0. We have mg, which is 100 newton, which is basically the weight of the box given to us. Theta, we already know theta. We can plug in the numbers. This is 100 times sine theta, which becomes 50 newtons. So 50 newtons is our tension. So now we're going to find out forces in the y direction. They are again, as the object is at rest, so they are equal to 0. We have the normal force minus mg cosine theta, cosine 30 degrees is equal to 0. So make them both equal. We know mg, we know the angle over here, we know the so now after calculating, which is an easy calculation, the normal force is 90 newtons. So from the answer list, D is our answer.
Okay, now we are doing question number 20, and the question is, as shown in the figure below, two blocks of masses m1 is equals to 12 kg and m2 is equals to 4 kg are connected by a massless pot passing over a massless and frictionless pulley. When the heavier block of mass m1 is released from rest, it falls through a vertical distance of h, which is equals to 1.6 meters. Before hitting the ground, find the speed of the lighter block of mass m2 at the instant the heavier one hits the ground. Okay. Okay. First we do the free body diagram for both the masses separately. So in case of mass 1, it will have a weight which will be equals to m1g and a tension upward because it's connected with a string, and it will accelerate downward because it's heavier. Its mass is 12 kg. So its force equation will be m1g minus t is equals to m1a. And for mass 2, tension will be in upward direction and weight as always in the downward direction, and it will accelerate upwards. So T minus m2g is equals to m2a. We have these two equations. We will solve them simultaneously to calculate acceleration. So we just do the maths here, and our acceleration will be 5 meter per second square. So now we need to find the final velocity of the lighter, the lighter block. So V final square minus V initial square is equals to 2as, and since it was at rest at the beginning, its initial velocity will be 0. So our final velocity will be equals to Vf final is equals to 2 times 5 is our acceleration, and our distance will be 1.6. This block will move 1.6 meters downwards, and this will move 1.6 meter upward. So the Vf square is equals to 16, and then Vf is equals to 4 meter per second.